February 1st, 2003. The Space Shuttle Columbia was supposed to glide out of the morning sky and land smoothly at Kennedy Space Center in Florida at exactly 9:16 a.m. Eastern Time. Inside Mission Control in Houston, the atmosphere was calm. Engineers monitored screens. Flight controllers prepared post-landing procedures. Families of the astronauts were already gathering. Television crews were setting up cameras near the runway. After 16 days in orbit, Columbia's mission appeared complete. Routine, successful, safe. And that word safe mattered more than anyone realized, because at that exact moment, while NASA prepared to welcome the crew home, something catastrophic was already happening inside the shuttle's left wing. At 8:58 a.m., one of the flight controllers noticed a strange sensor reading. A temperature measurement from the left wing suddenly disappeared. At first, it did not look catastrophic. Sensors failed sometimes. Electronics behaved unpredictably during re-entry. The shuttle was traveling through plasma hotter than several thousand degrees Fahrenheit. Small anomalies happened. Then another sensor disappeared. Then another. Then another. Inside Mission Control, the room slowly changed. People who had spent years around spacecraft understood patterns. And this pattern looked wrong. Very wrong. One engineer later described the feeling as watching the shuttle die piece by piece on a computer screen. At 8:59:15 a.m., Columbia was moving over Texas at nearly Mach 18, traveling faster than a rifle bullet, when superheated plasma inside the left wing finally destroyed critical structural supports. The wing began tearing apart. The shuttle started rolling and yawing uncontrollably. Commander Rick Husband attempted to respond. Mission Control called Columbia one final time. "Columbia, Houston, we see your tire pressure messages." Rick Husband answered calmly. "Roger, The transmission cut off, and 73 seconds later, the Space Shuttle Columbia disintegrated across the skies of Texas. 7 astronauts were killed. Debris rained down across forests, highways, and small towns for hundreds of miles. Millions of Americans saw it happen live on television. But the most disturbing part of the Columbia disaster is not the breakup itself. It is the fact that engineers had already warned NASA something might be terribly wrong 16 days earlier, and nobody listened hard enough. Stay with me. Because this story is not just about a shuttle accident. It is about what happens when successful organizations slowly stop fearing danger. It is about how institutions become so comfortable with risk that warning signs stop feeling like emergencies and start feeling like background noise. And it is about an engineer named Rodney Rocha, who spent 16 days trying to get NASA to look more closely at a problem that may already have doomed the crew of Columbia. The mission began on January 16, 2003. At Kennedy Space Center, the weather was clear and bright as Space Shuttle Columbia stood on Launch Pad 39A, attached to its massive orange external fuel tank and twin solid rocket boosters. Columbia was not just another shuttle. It was the first shuttle, the oldest orbiter in NASA's fleet. First launched in 1981, Columbia represented the beginning of America's reusable spacecraft era. By 2003, it had completed 27 missions successfully. It had carried astronauts, laboratories, satellites, and scientific experiments into orbit for over 2 decades. NASA trusted Columbia. The astronauts trusted Columbia. And maybe most importantly, the institution trusted itself. At 10:39 a.m. Eastern Time, Columbia lifted off. The solid rocket boosters ignited with nearly 7 million pounds of thrust. The ground shook. Smoke and flame poured across the launch pad. Slowly at first, then rapidly, the shuttle climbed into the Florida sky. For the first minute of flight, everything looked normal. Then, 81 seconds after liftoff, something happened that only a few cameras captured clearly. A large chunk of insulating foam broke away from the external fuel tank. The foam was roughly the size of a small suitcase. Traveling at hundreds of miles per hour, it slammed directly into the leading edge of Columbia's left wing. The impact lasted less than a second. No alarms sounded inside the cockpit. The astronauts had no idea it happened. From the ground, the strike looked insignificant. After all, it was only foam. Lightweight insulation, not metal, not concrete. Not an explosive object, just foam. But in physics, velocity matters more than material, and the shuttle was moving at nearly 1,500 miles per hour when the collision occurred. The impact force was enormous. Later testing would show the foam strike punched a hole through one of the reinforced carbon-carbon panels, protecting the wing's leading edge. A hole roughly the size of a dinner plate. At the moment of impact, Columbia was already doomed. Nobody inside NASA fully understood that yet, but a few engineers immediately became deeply concerned. Because foam strikes were not new. NASA had seen them before, and that was exactly the problem. Over years of shuttle missions, insulating foam had repeatedly broken away from external tanks during launch. Engineers had documented it, investigated it, discussed it in meetings. After each successful mission, the danger gradually felt less urgent. This phenomenon has a name: normalization of deviance. When dangerous events happen repeatedly without causing immediate catastrophe, organizations slowly stop treating them as dangerous. The abnormal becomes normal. And by 2003, foam shedding had become normal inside NASA. What once would have caused panic had slowly transformed into maintenance paperwork. A known issue, a manageable issue, an acceptable risk. But this strike looked different. The foam piece appeared unusually large, and the location of the impact terrified some engineers. Because the shuttle's wing leading edge was one of the most critical thermal protection areas on the entire spacecraft. During re-entry, temperatures outside the wing exceeded 3,000 degrees Fahrenheit. The reinforced carbon-carbon panels along the wing existed for one purpose: to keep plasma out. If those panels failed, superheated air would enter the wing structure during descent. And once that happened, the shuttle would burn apart from the inside. One of the engineers who immediately recognized the danger was Rodney Rocha. Rocha worked in NASA's Thermal Protection System group. Quiet, analytical, respected. The kind of engineer who understood details most people never think about. He studied heat shield systems, tile damage, re-entry physics, the specific way spacecraft survive atmospheric descent while surrounded by temperatures hotter than molten steel. When Rocha reviewed footage of the foam strike, he became increasingly uneasy. The impact looked severe, and there was one horrifying reality nobody could escape. NASA did not actually know how much damage had been done. That uncertainty became the center of the entire disaster. Because once Columbia reached orbit, the only way to determine the extent of the damage was to inspect the wing in detail. And NASA had limited capability to do that internally. The shuttle did not carry robotic inspection equipment at the time. The astronauts could not easily access the wing leading edge during a spacewalk, which meant NASA needed external imaging. High-resolution photographs, military satellites, ground telescopes, anything capable of showing whether the wing had been critically damaged. Rodney Rocha and several engineers began pushing for those images almost immediately. They attended meetings, raised concerns, requested Department of Defense support. At first, the discussion seemed routine. NASA management acknowledged the request. People talked about analysis. Engineers debated probabilities. But slowly, over the next several days, something dangerous happened inside the organization. The discussions stopped focusing on uncertainty and started focusing on reassurance. This is the point where the Columbia disaster becomes less about engineering and more about psychology. Because the managers overseeing the mission had already absorbed years of shuttle experience that shaped how they interpreted danger. Foam strikes had happened before. Shuttles survived before. Therefore, the assumption became that Columbia would probably survive too. Probability replaced investigation. Confidence replaced urgency. One NASA manager reportedly described the foam strike as a maintenance issue rather than a safety of flight issue. That phrase mattered enormously, because once leadership mentally classified the damage as non-catastrophic, the need for additional evidence immediately lost urgency. The engineers still wanted answers. Management increasingly wanted closure. He wanted the Department of Defense to use powerful ground-based telescopes or reconnaissance satellites to photograph Columbia's left wing in orbit. The military possessed imaging capabilities capable of identifying surprisingly small details from space. If NASA obtained those images, engineers might determine whether the wing leading edge had suffered catastrophic penetration. And if severe damage existed, maybe the astronauts could do something. Maybe repairs could be attempted. Maybe contingency plans could be explored. Maybe another shuttle could even launch for rescue. But none of those possibilities mattered unless NASA first accepted the damage might actually be fatal. And that acceptance never fully happened. The request for military imaging moved upward through management channels. Meetings occurred, emails circulated, discussions happened behind closed doors. But as the request climbed the hierarchy, it encountered something invisible and powerful: institutional momentum. NASA in 2003 was under intense operational pressure. The shuttle program had become deeply tied to schedules, budgets, international commitments, and political expectations. Missions delayed scientific experiments. Delays affected construction planning for the International Space Station. Every launch involved enormous logistical coordination. And after more than 100 shuttle flights, the organization had quietly developed a dangerous belief: the system works. Even when problems occur, the system survives. This mindset changes how organizations process warning signs. Instead of asking, "What if this is catastrophic?" they begin asking, "Why should we believe this is different from previous missions?" That subtle psychological shift can become deadly, because it transforms uncertainty from a reason for caution into a reason for optimism. Inside engineering meetings, some analysts attempted to model the foam impact using computer simulations, but the simulations had major limitations. The exact size, speed, angle, and density of the foam strike remained uncertain, and without actual imagery of the damaged wing, nobody could accurately verify the models. Some simulation results suggested limited damage. Others hinted at catastrophic penetration. The data was incomplete. The uncertainty remained unresolved. Rodney Rocha later described feeling deeply frustrated during these meetings. He believed leadership was prematurely dismissing worst-case scenarios. At one point, he reportedly wrote internal emails expressing concern that the issue was not receiving sufficient attention. But the structure of the organization made escalation difficult. NASA's hierarchy filtered information through layers of management before it reached top decision-makers. And every layer subtly reshaped how risk was communicated upward. Strong concerns became moderate concerns. Moderate concerns became technical discussions. Technical discussions became routine operational issues. By the time information reached senior leadership, the emotional urgency engineers felt at the working level had often disappeared. This pattern had happened before, and 17 years earlier, it had already killed another shuttle crew. After Challenger exploded in 1986, investigators discovered engineers had repeatedly warned NASA about O-ring failures in cold weather. Those warnings existed, they were documented, but organizational structures diluted them until management no longer perceived the danger with the same intensity engineers did. Now in 2003, history was repeating itself. Different shuttle, different technical failure, same organizational behavior. As Columbia orbited Earth during its 16-day mission, the astronauts remained unaware of the full extent of concern on the ground. They performed experiments, conducted research, spoke with reporters and students, sent video messages home, laughed, worked, floated weightlessly through the shuttle's modules while engineers on Earth quietly debated whether the spacecraft was damaged beyond repair. And here is the terrifying part. Later investigations suggested Columbia's crew might actually have been saved. Not easily, not safely, but possibly. NASA had another shuttle, Atlantis, already being prepared for launch. Under extreme emergency procedures, Atlantis could potentially have been rushed into a rescue mission. Columbia's astronauts might have powered down systems to conserve supplies while awaiting rescue. None of this would have been simple. The risks would have been enormous, but it was technically possible. The tragedy is that NASA never fully explored those rescue scenarios during the mission, because leadership never fully accepted the possibility that Columbia was doomed. And without that acceptance, urgency never reached the level required for extraordinary action. By the final days of the mission, the organization had largely convinced itself the shuttle would survive re-entry. The uncertainty remained unresolved. But psychologically, the outcome already felt decided. Safe return became the default assumption. On February 1st, 2003, Columbia began re-entry over the Pacific Ocean. The orbiter rotated belly first into the atmosphere exactly as designed. As air compressed beneath the shuttle at hypersonic speed, temperatures outside the spacecraft rose to thousands of degrees. Normally, the reinforced carbon-carbon panels along the wing protected the vehicle from these unimaginable conditions. But Columbia's left wing was no longer sealed. During re-entry, superheated plasma entered the hole created by the foam strike. Inside the wing, temperatures climbed catastrophically. Aluminum structural supports began melting. Sensors started failing. One by one, telemetry vanished from mission control screens. Temperature sensors. The Columbia disaster became more than a shuttle accident. It became a case study taught in universities, military academies, aviation programs, and engineering schools around the world. Not because the physics were complicated, but because the organizational behavior was terrifyingly familiar. Large systems develop momentum, and once momentum becomes psychologically tied to identity, schedules, budgets, or prestige, warning signs start feeling inconvenient rather than urgent. That pattern appears everywhere. Airlines, oil rigs, nuclear plants, hospitals, military operations, technology companies. The technical details change. Human behavior does not. After Columbia, NASA grounded the shuttle fleet for more than 2 years. Foam shedding was aggressively addressed. Inspection systems improved. On-orbit repair procedures were developed. Future shuttle crews gained the ability to inspect wings in orbit using robotic systems. But no redesign could erase the deeper lesson Columbia revealed. Successful organizations are often most vulnerable precisely when they believe they understand their systems completely. Because success slowly trains people to reinterpret danger as survivable. Foam strikes survived once, twice, 10 times. Eventually, survival itself becomes evidence that the danger is acceptable, until the day it is not. Rodney Rocha never became a household name. He was not a celebrity whistleblower. He was an engineer trying to answer a simple question. Is the wing damaged badly enough to kill the crew during re-entry? For 16 days, he kept asking for more data, better imagery, more certainty, more investigation. And in the end, Columbia re-entered Earth's atmosphere carrying 7 astronauts inside a spacecraft. Nobody fully understood anymore. The engineers saw uncertainty. The institution saw routine risk. And somewhere between those two interpretations, the shuttle burned apart over Texas at 17,000 miles per hour. The next time someone inside an organization asks for more time, more evidence, or more verification before moving forward, remember Columbia. Because catastrophic failures rarely begin with explosions. They begin with warning signs powerful systems slowly learn to ignore. And sometimes the most dangerous sentence inside any institution is not, "We know there's a problem." It is, "We've seen this before." Temperature sensors, hydraulic systems, tire pressure indicators. Flight controllers watched the failures spread across the left wing like a disease. Inside mission control, voices became quieter. People leaned toward their screens. The pattern no longer looked random, it looked fatal. Then came the final transmission. "Columbia, Houston, we see your tire pressure messages." "Roger." Silence. Seconds later, the shuttle's left wing structurally collapsed. Aerodynamic forces instantly overwhelmed the orbiter. Traveling at nearly 17,000 miles per hour, Columbia broke apart over Texas. Witnesses on the ground described multiple streaks of light crossing the sky. Some thought they were meteors. Others realized immediately something terrible had happened. Debris scattered across hundreds of miles. The crew cabin separated from the orbiter and continued briefly upward before falling back toward Earth. 7 astronauts died. Rick Husband, William McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, Elon Ramon. The nation watched in horror, and almost immediately, investigators began asking the same question that followed Challenger.
Who knew?
The Columbia Accident Investigation Board uncovered a deeply uncomfortable truth. The physical cause of the accident was simple. The foam strike breached the left wing. But the organizational cause was far more disturbing. NASA's culture had normalized dangerous behavior. The board concluded that the agency's institutional mindset played a direct role in the disaster. Engineers raised concerns. Managers minimized them. Critical uncertainty failed to trigger emergency action. And previous success created overconfidence that blinded the organization to accumulating risk. The investigation specifically criticized NASA's communication structure. Information moved upward through layers of hierarchy that gradually softened warning signals. The descent became difficult. Confidence became rewarded. Operational momentum became more powerful than unresolved uncertainty. Rodney Rocha later spoke about how devastating the experience was emotionally. He believed stronger action should have been taken, believed imagery requests deserved higher urgency, and perhaps most painfully, he believed the organization never fully listened to the engineers closest to the technical systems. That sentence echoes throughout engineering history. The people closest to the danger are often the people with the least institutional power. The Columbia disaster became more than a shuttle accident. It became a case study taught in universities, military academies, aviation programs, and engineering schools around the world. Not because the physics were complicated, but because the organizational behavior was terrifyingly familiar. Large systems develop momentum, and once momentum becomes psychologically tied to identity, schedules, budgets, or prestige, warning signs start feeling inconvenient rather than urgent. That pattern appears everywhere. Airlines, oil rigs, nuclear plants, hospitals, military operations, technology companies. The technical details change. Human behavior does not. After Columbia, NASA grounded the shuttle fleet for more than 2 years. Foam shedding was aggressively addressed. Inspection systems improved. On-orbit repair procedures were developed. Future shuttle crews gained the ability to inspect wings in orbit using robotic systems. But no redesign could erase the deeper lesson Columbia revealed. Successful organizations are often most vulnerable precisely when they believe they understand their systems completely. Because success slowly trains people to reinterpret danger as survivable. Foam strikes survived once, twice, 10 times. Eventually, survival itself becomes evidence that the danger is acceptable, until the day it is not. Rodney Rocha never became a household name. He was not a celebrity whistleblower. He was an engineer trying to answer a simple question. Is the wing damaged badly enough to kill the crew during reentry? For 16 days, he kept asking for more data, better imagery, more certainty, more investigation. And in the end, Columbia re-entered Earth's atmosphere carrying 7 astronauts inside a spacecraft nobody fully understood anymore. The engineers saw uncertainty. The institution saw routine risk. And somewhere between those two interpretations, the shuttle burned apart over Texas at 17,000 miles per hour. The next time someone inside an organization asks for more time, more evidence, or more verification before moving forward, remember Columbia. Because catastrophic failures rarely begin with explosions. They begin with warning signs powerful systems slowly learn to ignore. And sometimes the most dangerous sentence inside any institution is not, "We know there's a problem." It is, "We've seen this before."